Right, and this one we're going to look at solving some equations. X squared minus 16. Well, one method is we could add the 16 over here and get x squared equals 16. We could take the square root of both sides. Now, when we take that act of taking the square root of both sides, there are two possibilities for our answers. We will always have a positive or negative option. This is different than if we had just had an equation with the square root of x, and we looked at the domain and range of the square root of x to prove that earlier in this unit. But there's an option. X could have been 4. 4 squared gives me 16, or it could have been negative 4. Now let's look at number 2, and look at the difference here. To get 16 to the other side, I'm going to have to subtract it this time. So x squared equals negative 16. Now, I'm going to do the same technique. Take the square root of both sides. When I do that, I always have a negative or positive option. But the square root of negative 16, aha! We know how to handle that now. Anytime we have the square root of a negative number, that means we're going to have an imaginary answer. So that's 4i. Look at number 3. X squared minus 50. It's going to be x squared equals 50. Square root of both sides means I'm going to have a positive and negative answer. And 50, we know that's 25 times 2. So that's 5 square roots of 2. On the other side, x squared equals negative 50. X equals positive or negative. And if you're catching on, 5 root 2 I. Because when we take the square root of both sides, we have the positive and negative option, and the square root of a negative number is imaginary. Now let's see what happens here. I wonder if I can do the same technique. Instead of having to square all that out and everything, let's try adding the 18 over there. I wonder if I can take the square root of both sides. Now when I do, I know I need to have a positive or negative option on that right side. And then the square root of 18, that's 9 times 2, so 3 root 2. Ooh, now let's see what I can do. Still trying to get x by itself. Could I add 3 to both sides? Sure. So that's 3 plus or minus 3 root 2. And then divide by 2? Sure. Why not? Nice. Let's try that same technique over here. But here I'm going to have to subtract the 24. So that's going to be a negative 24. I bet I'm going to have an imaginary answer because I'm going to take the square root of both sides. No, I'm going to have two answers, definitely. We're always going to have plus or minus. And then that's going to be 24. I know that's 4 times 6. That's 2. Square roots of 6. But I better take an I out because it was imaginary. Now I want to get x by itself. So I need to get rid of that to minus 2. So let's add 2 to both sides. And then divide by 3. That's really nifty. Wish all problems worked like that. Alright, next one. Uh-oh, cubic. Ooh. Hey, let's get an x. Let's try factoring out an x. Because I know Miss Nice always said, if you can factor out something, you better do it. Now, I wish that factored some more because that would be so nice. But 28 is not a perfect square. But if I have two factors that multiply together to give me 0, that means either x is 0 or x squared minus 28 is 0. Oh, well, that looks like some of the ones I've been solving from the beginning, so this is good. X squared equals 28. Square root both sides. I'll get plus or minus the square root of 28. Square root of 28. 28 is 4 times 7, so that's 2 root 7. Okay, number 8. Factor out an x. Starting to get the hang of this. That's going to give me x equals 0 here. X squared plus 32 equals 0. Subtract the 32. Take the square root of both sides. X equals plus or minus square root of 32. 16 times 2. So that's going to be 4 root 2. It's imaginary, so I better take an I out. Now, I want you to think back through on what we actually have here. On number 1, we have 2 solutions, and they're both real numbers. So if we looked at the graph, we actually would have 2 x-intercepts as well. What about number 2? We have 2 solutions, both imaginary. Do you think you're ever going to actually touch the x-axis? No, you don't have any real roots, so you never actually touch the x-axis. What about here? What kind of solutions do we have? We have 2 irrational, but real. So yes, you would have 2 x-intercepts. Here, you have 2 imaginary. So, no, you would not have any x-intercepts. Here, 2, because you have a positive and negative answer, irrational, so you would have 2 x-intercepts. 2, plus or minus, imaginary or complex, actually, because we have a real part and an imaginary part. No x-intercepts. What about this third one? I have 1, 2, 3. 3 real answers. So 3 x-intercepts. 1 real, 2 imaginary. How many x-intercepts would I actually have? I would only actually have 1. So I want us to get that idea that we can have a solution, something that is an actual 0 for the equation, but is not an x-intercept.